We're dealing with angle measures and angle bisectors. And again, these things should be somewhat familiar in the sense that you've used the terminologies of angles before, I hope. But we are going to introduce a few new ones. Um, Angles, you're probably pretty aware of what an angle is. Let me adjust this for a sec. Yeah, you can see it. Um, an angle is formed with two rays, right? So we have two rays, go off infinitely in both directions, um, and they meet here with this same endpoint. This endpoint we're going to call the vertex. So the vertex of the angle is the pointy part of the angle. It's where the angle originates. You can think of it. Um, Also, we're going to call these rays here sides. So an angle has a vertex and two sides. Pretty doable, right? We're going to describe it by doing this little angle mark. So we're going to call this angle here angle, little angle mark PQR. Whenever we label angles, we always put the vertex in the middle. So we can label this PQR, or we can go the other way and label it RPQ. So either one is totally fine. Okay, so what's this one? Right? What is this angle here? Oh, there's a third way. I forgot to mention that. We'll get to it. So the vertex is what? The vertex is this point here. And even though they don't have a little dot, because there's an angle here and it's pretty clear that there's two rays, you can imagine that there's a little dot there. You don't really need the dot to know that there's a point K, right? So therefore, the vertex is point K. A name for that angle, we could also name that, we could use our earlier names of LKJ, or angle LKJ and angle JKL. That'd be those two. Another name we could do, and this only works if there's one angle that uses that point K as a vertex, and that is to just call it angle K. For the most part, we're not going to imagine that this is an angle here or something like that. We'll just call this angle K. The angle is numbered, so therefore another name for that angle there is angle 1, because there's a 1 there. So a couple different ways to name it. You can name it just with the vertex if it's the only angle using that vertex, only angle with that vertex. You can label it with point, vertex, point in any order, or you can look for a number. Sometimes there's a number. Okay, go ahead and answer these questions. I'll pause here for a second. So pause. Without seeing a figure, is it possible to give another name for angle MKG? If so, why not? Yes, it is possible. You know that M and G are points on the rays. K is the vertex, so therefore GKM is totally possible. Oops. Angle GKM. Don't forget the little angle thing, like I did. Number 4, name angle 2 in as many different ways as possible. Sorry, I'll scroll down for this one. You should be able to see that one in your book. But angle 2 is this one. Again, I'll just highlight it. So this is angle 2. So we know the first name, that's angle 2. We can also give it the 3-letter definition. We can go AEB or BEA. There's a temptation to call it angle E. And why can't we call it angle E? Well, the problem with calling it angle E is that one could be angle E, but this one could also be angle E, and this one could also be angle E. So there are 3 angles that share that same vertex, so we can't really call this specific angle E. It's just not clear. And we want to be clear when we're talking to someone. Oh, hey, angle E. Someone needs to know what you're talking about there. Okay, these terms should also be somewhat familiar to you. If you have a right angle, it is 90 degrees. We mark it with this little sign here to show that it's 90 degrees. Acute angles are less than 90. Obtuse angles are greater than 90, and then a straight angle, it's not going to come up. But so I don't know why this is in your book. You don't really need to know that. Okay. Oh, okay. So for this one, we need to draw an angle of a certain amount. And you can go ahead and do this in a blank sheet of paper or something like that. But sometimes it's pretty difficult to do some of these constructions. I'll try and use this. So the book lists some steps, and I'll just go through it just so we're all on the same page. Use a straight edge to draw ray AB. So here's a point. Okay, so I'm going to put this here. I'm going to put an arrow here. Boop, doop. Okay, this is point A. Somewhere along here is point B. So this is ray AB. It says place your protractor on point A. So I need a protractor, which is that thing. On point A so that AB is at 0. So in this case, we're going to use the inside numbers, right? So it's 0, 10, 20, 30, 40. Ignore the outside numbers. Be super careful whether you're using the outside numbers or inside numbers. That's by far the #1 mistake when using protractors. So we want to place our protractor on point A so that AB is 0. It says locate a point along the edge of the protractor that corresponds to 138 degrees. So a lot of people will say, oh, look at this, 138 degrees is over here. No. Remember, if this is 0, then we're going 10, 20, 30, 40, 50, 60, 70, 80, 90, 138 is way over here. So, oh, I always write again. So that's 138. So again, be careful. Mark that location, label that point C. Okay, so I'll get rid of this. And I didn't do a good job marking. That's point C. And then finally it says to draw ray AC. Oops. It should be easier in real life than using one of these weird things. Here's ray AC. I forgot to draw the arrows at the end. That's okay. Forgot. Finally, it says here that the M refers to the measure of the angle. So the measure, or the actual number of degrees, because that's what you measure angles in, of angle CAB. So CAB is 138 degrees. So let's see how accurate I was. Yeah, it's pretty accurate. I'm going to scoot this whole thing over and see if... Yeah, that wasn't bad, right? Yeah. Okay. I want you to go ahead and try. See if you can do 7 and 8 real quick. Forgot to tell you to pause, but you should have paused. Okay, each angle will be found on the rigid frame or bicycle. Use a protractor. So you slap a protractor down. Of note here, you got to be a little bit careful. Some folks have trouble with protractors. Where'd my protractor go? Not that one. Where is it? Oh, it's up top. I left it up there, and I got a bunch of copies. Okay, sorry. So you plop a protractor down. The very center of your protractor goes on the vertex. Again, we want to make sure we're reading the proper numbers here. So this is 10, 20, 30, 40, because we start at 0. So this one's about 40 degrees. Oh no, I have to rotate this one. Because I have to rotate it, that means I need to either line it up with this ray, or I can keep rotating and line it up with that ray. Either one is fine, but again, I have to read the correct number. Whatever ray I line it up with, that's going to be 0. So in this case, I'm going to line it up like this. That means this here is 0, right? And then I start counting up. So I go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 105, I guess. You should be able to tell just at a glance whether or not an angle is greater than or less than 90. So if I look at this and go, oh, it's less than 90, then my answer should be less than 90. If I look at this and go, it's more than 90, then my answer should be more than 90. If you read the wrong side of the protractor, you'll get that mixed up. So that's kind of just a way to check to see if you're in the right ballpark. Okay, a few more terms. Angle bisector is a ray that divides an angle into two equal parts, right? So bisecting, we did this with a segment bisected. We can do it with an angle. So blah, blah, blah. There's a postulate. So again, this postulate is something that we're going to assume as true given the book. We don't have to do a proof for this. So this postulate is called the angle addition postulate. And it basically says that if S is interior, so this isn't an angle bisector, right? It doesn't bisect it into even parts necessarily. But if it's an interior angle, right? So PQR is the larger one and angle, S is in the interior. Then it says the measure of angle PQR, so PQR is equal to the sum of the other two angles, right? So this makes sense if we can pick some numbers for this, right? And you can see this in your protractor. If say this is, it looks like 80 degrees, and if this is 40 degrees, how much is the whole thing, right? Well, 80 plus 40 equals, 120. So it's common sense, but we still need to have a reason to say that that's true. And so that's what the angle addition postulate is for. Okay, go ahead and see if you can do this using the steps in your book. We'll do another little pause real quick. Pause. Okay, I'll just work through this one. An angle bisector, oops, using just a compass, not a protractor. Don't want a protractor. You could use a protractor. Protractors are lame. We want to use a compass. Compasses are cool. So check this out. Okay, because compasses are a way to do things without measuring things. Whoa, okay. And we'll do black, sure. Make a little arc. And move this over here. But I'm going to make 3 arcs between my, after my first arc, I can change the aperture, the opening of my compass, but I want to keep it absolutely the same between the second and third. So I'll go to a different color, I'll change it a little bit. But for these 2 steps, you want to keep it exact same. So I'm going to make another arc here. Make it go all the way in the middle. There we go. And then another arc here. And hey, guess what? Those 2 arcs cross at a point that is exactly in the middle because they're both equidistant from these 2 points, which are equidistant from this. So therefore, they're in the middle. And I can use my sweet straight edge. And I can do a nice angle bisector there, boink. And I perfectly bisected that. It doesn't look off at all. Hopefully it looks a little better on your paper. A few more here. Just some questions. Go ahead and pause here. What's the relationship between a segment bisector and an angle bisector? Well, they both bisect things. They just bisect different things. When you copy an angle, do the length of the segments you draw to represent the 2 rays affect whether the angles have the same measure. Right? So it's basically saying we're taking someone else's angle and copying it down. And at some point, you're drawing rays, but rays are infinite, right? You can't draw a ray, so therefore you're using segments. Does the length of the segment matter? No, it doesn't, because the segments here are just in place of rays. They go on forever. So the length of those things doesn't matter. There we go. Many protractors have 2 sets of degree measures around the edge. When you measure an angle, how do you know which of the 2 to use? I covered this one. You make sure that your first ray lines up with the protractor. So your first ray lines up with the edge of the protractor. The second, and then that's 0, right? So you count up from 0, 1, 2, 3, 4, 10, 20, 30, 40, 50, whatever that is. Or another way to think of it is if it's an acute angle, it should be less than 90. If it's an obtuse angle, it should be more than 90. Something like that. All right, that's all I got. Yeah, have a good one.